Hi guys, let's talk about sketching an angle in standard position. So I'm going to teach you how to think through this in a way that you can reconstruct it when you need to. So let's do this, and let's get something bright, and let's talk about a circle. All right, and on this circle, let's divide it into some parts. Let's say we want to split it here and maybe here. And when we're talking about this circle, we'll start at 0, and then up here or over here is pi. And if I went all the way around the circle, this would be 2 pi, just to orient us. And so up here at the top, if we go 180 across the top, the very top is going to be pi over 2, which is 1/2 of pi, right? It's halfway to the pi. And then when we go around down to here, this is 3 pi over 2 because it's 3/2, or 1 goes halfway around the circle, and then another quarter or another half. So 3/2 is 1.5 around this here circle when 2, I can't believe I just said that, this here circle, when 2 pi is a full circle. Okay, so now the next thing we want to do is we want to divide our circle into fourths. I'm trying to do this somewhat neatly. Okay, so if 90 degrees is pi over 2, then when we're dividing this, this would be a fourth, and this would be pi over 4. Okay, so if you think about up here, this equals pi over 2 pi over 4, because if you cancel that, you'd have 1/2, right? So if we're going to keep counting here. So here is pi over 4. Here is 2 pi over 4. Here is then 3 pi over 4. This is really just a lot of fractions going on. And this pi right here would be 4 pi over 4, and you can see that that would equal pi because the 4's would cancel. Here would then be 5 pi over 4. Down here would be 6 pi over 4, which you notice would cancel to be 3 over 2. And then here, so that was here, here is 7 pi over 4. And then when we get to the end, we have 8 pi over 4, which would cancel to be 2 pi. So we have split this into actually 8 pieces. 1, 2, 3, 4. So that's splitting pi into 4 parts, because remember each circle is 2 pi. So the top part is 4 parts, 4 out of 4 pi. And then the bottom is 1, 2, 3, 4 more parts. So we're just thinking about the circle split into fourths in order to know where these angles are. So just to orient you a little bit more, this equals 90 degrees. So here we're talking pi over 2 and 2 pi over 4. We're talking about radians. And at the top of the circle here, that equals 90 degrees. Over here we have 180 degrees, just to keep you oriented, because from the 0, we spin around 180 degrees and land there. And then down at the bottom, this would be 270 degrees, is the same as 3 pi over 2. And then when we finish over here, this is 360 degrees after we go around one time. All right, this in mind, let's think about this circle. it says sketch pi equals, or I'm sorry, not pi, theta equals negative 7 pi over 4. Well, forget the negative for just a second. 7 pi over 4 is right here. So if I had started here on the 0 and I went around this circle, this right here is 7 pi over 4. It takes, actually, I forgot to tell you that this is 45 degrees, but maybe you realize that. And so can you see that this is 45 degrees less than a circle? It is 315 degrees. Each one of our little sections is worth 45 more. So up here is 90, and then 90 plus 45 is 135. We don't always have to keep converting back to degrees, but sometimes when you're first talking about radians, it helps. We have 180 plus 45. Right here would be 225 degrees. And then we get down here to 270, and then over here to 315. But so we would draw this particular angle and this particular line if it was positive. But go back up here, it's actually negative. And so when we have negative just means go clockwise. Okay, positive always in math is counterclockwise. So going back to our circle, we are going to go the other direction. We're going to do exactly the same amount. We're going to go around 315 degrees, but we want to go negative 7 pi over 4 or negative 315. And so we're going to start here and go around our circle. We're to 180 backwards. We're to 270, and we're going to do it to here. And so the angle we want to draw is actually a 45-degree angle because we went in the negative direction. Negative is counterclockwise. And we went this way. And we want to draw this angle right here. And so this right here is negative 7 pi over 4. Okay? And then this circle has gotten kind of busy, so I'm going to drop down here and show you some more divisions that we often see on a circle. You don't always divide it into fourths. Oh, really? Come on. Help me out here. There we go. I'll go ahead and draw these lines to orient it. That's the x-axis. This is actually the y-axis. Sorry, it's not perfectly straight. And this time I want to divide into sixths. Thirds and sixths. I'll show you why they actually are very much the same thing. So instead of and this, what we call the unit circle, the more you can draw on it, that was not even at all. I'm going to do that one over again. This is still not perfect, but I'm trying to make it so that it at least makes some sense. Okay. Let's put some measurements on here. So this, just to orient us, is 30 degrees, right? From here to here. from here to here is going to be 60 degrees. And from here to here is 90 degrees. So we can keep talking like that, but we're basically going to divide our circle into 1, 2, 3, 4, 5, 6. So pi is going to get divided into 6 pieces, 7, 8, 9, 10, 11, 12 for the whole 2 pi. All right, so when we go 30 degrees, and you could use unit conversions for this too, 30 degrees is the same as pi over 6. So 60 degrees is the same as 2 pi over 6, or pi over 3, if you simplify it. Okay, and when we get to 90 degrees, it is still pi over 2. But notice what else we could call it. We could call it 3 pi over 6. So 1, 2, 3. That's the same as pi over 2, or 1/2 pi. When we get to here, let's call this 4 pi over 6, or 2 pi over 3. This is 5 pi over 6, or it doesn't really simplify, so let's take that off. This is 6 pi over 6, or our good old pi, which is half of a circle. 7 pi over 6, 8 pi over 6, which is the same as 4 pi over 3. We have 9 pi over 6 equals, you guessed it, 3 pi over 2. 10 pi over 6 is the same as 5 pi over 3. 11 pi over 6 is what it is, and 12 pi over 6 equals 2 pi. We're just dividing our fraction, our circle, into fractions. The pieces are in sixths here. And the weird thing about it is that 1 pi is 180 degrees, or a half circle. So we're doing whole circles in terms of 2 pi, which might make it just a little more confusing. But so if I want to know what negative 2 pi over 3 is in standard position, let's talk about what 2 pi over 3 is without talking about any negatives. Let's say, there it is up there. So if I went here and I went this much, I could draw this angle like that as 2 pi over 3. But remember, negative means counterclockwise. Whoops. Silly me. Positive is counterclockwise. Negative is clockwise. I always think about math being somewhat backwards. So we actually want to do the same amount going backwards. We're going to go 2 pi over 3. And so we're going to do this. Just use the same blue going backwards. So we want to go like this. I think of it as one slice past 90 degrees going the other direction. So this angle right here could also be negative 2 pi over 3, because it's just the same as this one, only going backwards. So when we draw this problem, we're going to have an angle that goes something like this. It says sketch the angle. So this is what that angle would look like.